You can ignore the brackets and comma if you want. But if you think of those brackets and comma, what we're doing is defining what an acceptable function is. So if someone says, here's a complicated string of letters, is it a function? Is it something you can put your numbers in and get your f and g functions out? So for instance, is g of x acceptable?
Well, yeah, if we can have empty strings.
Oh, we'll go no e. Yep. No space e. Okay, yep. Sorry, yep. So lots of theoretical applications allow the e, lots of the practical applications don't. So I probably should have put the no e in there early on, because I forgot it was going to be practical. Really isn't me. So is g of x acceptable? No. And if we think about it in terms of math, g is a two-phase function, it needs two inputs. Is gx, colour, fx acceptable? Let's break it down. So g has to have two things coming from it, an x on one side and an fx on the other. Or maybe you want to do it this way instead. That one's going to get you in trouble. Because you can't break down xf into anything more. But if you break it down this way, and the x just finishes, the f of x, you use this rule, that goes to an x, and that finishes. So you want to know, how do I calculate this? As a computer program, that's fed in this string of calculations, this is all the computer gets, it breaks it down and says, right, I need the x as one variable, I need the fx as my other variable. How do I calculate that? I get my x, I feed it into my f, I take my x and my f of x and I feed them into the g. This is what a computer parser actually does when it's reading through and doing this. And that's why we have the brackets. Both computers and humans prefer if you do this, because it tells you where the comma is. It tells you where to break things up. That's all we're doing. Okay, so that's gx fx. If that's fine, then fx gx should also be fine, right? People are shaking their heads. That's not good. Why don't you like this? It's the same as gx fx.
Because you know for a fact that you're going to have two things following g. At least two things following g.
You know for a fact you're going to have two things following g that are going to be non-empty. So there's going to be at least two things after a g. There's going to be one thing after the g, so it sucks. Is that kind of the reasoning? Yep. Let's actually break it down. You're right, that is actually true and sufficient to reject it, but there's other reasons as well. So we're going to have to use the f to break it down, so the f's on the right hand side, the left hand side, the g isn't. There's going to be f of something, it's going to be f of xgx. Now there's no rule that breaks on xgx, so we're stuck. So you're right, if we ever did get down to gx, we'd be stuck. We also get stuck on the other side with the f as well. So a computer program would break down with the f has two variables, not one, I'm stuck. But you're right, as a human you can see g needs two variables, it's only got one. And that seems like a bigger problem to us as humans, because we just ignore extra variables. We say, here's two things, and you need one of them. Computers, it's just as problematic. Okay. This f and g stuff, we're going to be dealing with this a fair bit in weeks 9 and early in 10. We're going to be building and talking about these functions and manipulating